Hello, I'm going to talk about important steps of semiconductor fabrication, the lithography. Last week we learned about the importance of the clean room and some terms like FOSFI and FOOP and OHT process, and we learned about we should take on some garments to go inside the clean room. So today I'm going to talk about lithography. The lithography is we're trying to make some selective patterns. So we use the chemical materials called photoresist. We can see in this figure this black shape is the substrate and this thin layer is the photoresist. When we coat the photoresist on the substrate, then we expose some light and by using some reticles, so some selective part will be exposed to the light. So this process is called the lithography, and depending on the what materials we use for the PR. So some photoresist makes the bonds stronger or weak. So when we use when the PR photoresist makes the bond stronger, after we expose the light and we put inside the developer, the parts that we expose some light will be remain. But other case, if the photoresist make the bonds weaker, after we put inside the developer, the parts that exposed to light will be removed. So we can make the selective pattern like this way. And after, we can cut off some parts by intentionally. So this step is called etch. And after these steps, we put inside the stripper, so the remaining photoresist will be gone. So this process is called the lithography, and this slide shows about the reticle, that we use reticle in these steps to expose the light to the selective parts. So this mask is called reticle, and this slide shows about the alignment key, that we should make the alignment key well, because if there are some misalignments, there will be the overlay, so we should make it well. And this slide is about the pellicles that protect the reticles from some particles and dust. And this slide shows that the whole system of the lithography, and I will explain again. And first, we should the clean the vapor. There should not exist on the particle should not be exist on the vapor. So we should clean the vapor first, and we coat with the photoresistor, and then we should hit the vapor because of the PR. So we should remove some moisture and make the bonds between the vapor and the PR more stronger. That step is called soft bake, and after that step we should align the mask above the vapors, and we expose the light and put inside the developer, and then we hit the vapor again, because after the steps we put inside the developer, the vapor is wet, so we should remove some moisture and make stronger bond with vapor and photoresist. And this step is called hard bake. And then sometimes we should etch process, and then we remove the photoresist by the stripper. That is the whole curriculum of the lithography. And this slide shows there's 3 methods to make up patterns on the vapor. The first is the contact printing and proximate printing and project printing. But these 2 methods has some serious important problems. So nowadays we use this projection printing method the most. We learned about, and we use the stepper and scanner on the projection printing method, and in the projection printing method, we should know the numerical aperture and depth of the focus. These 2 concepts is the most important in this projection printing, because it helps to make the more detailed patterns. And after this time, in this video, I will paraphrase the numerical aperture is NA, and depth of focus is paraphrased by the DOF by the convenience. If we close the aperture, the amount of the light will come the less amount of light will come inside the aperture, and then these angles should angles will become more sharper, and the depth of focus will be getting longer. And this figure can be the good example of the this concept. If we close the aperture, the DOF will be shorter, and if we open the aperture, the DOF will be longer. So the concept of DOF is the important, because when we lithograph, if we make DOF shorter, in this part will be not expose the light. So we should make DOF longer enough. That's the important concept. And there is a Rayleigh's equations. So by the Rayleigh's equation, if the wavelength is shorter, and NA will larger, and the value of the CD will be smaller. We should make the values of the CD small, because we have to make the patterns detail more tiny. But if the NA is larger, the DOF will be smaller. So there will be some trade-off. So we have to find some balance of the. We have to find some balance. And this slide is about some photoresist. Is what is consists of, and we should know the one thing that depend on the amounts of depend of the exposure of the light. We can make selective patterns by the positive method and negative method. And when you coat the photoresist, we use spinning method, or deep coating, or spray coating. And there, in the spinning coating, there's some problems. So we should know, and there's some defects that when we coat the photoresist, if there is some particles on the wafer, there will be some defects, and this slide shows some problems problems when the particle exists. So cleaning the wafer is the important steps of the important steps. So it is an end of today's review.